Hello everyone, myself Simran from Team CloudyML and I welcome you all to our YouTube channel. Today in this video, we're going to solve a machine learning interview question asked by the interview round in the company ACCENTURE. So let's begin by looking at the question first. So this is the question. It is a bit huge question, but it is really very easy to understand once you hear it properly. Pay attention and concentrate on the question so that you don't get confused and understand the question properly. So we have Charlie. Charlie wants to buy a house. If Charlie noted F features, each row F contains space separated values followed by the house price in the dollars per square foot, making for a total of F plus 1 columns. If Charlie makes observations about H houses, his observation table has H rows. This means that the table has a total of F plus 1 into H entries. But unfortunately, he was only able to get the price per square foot for certain houses and thus needs your help in estimating the prices of the rest. Given the feature and pricing data for a set of houses, help Charlie estimate the price per square foot of the house for which he has compiled the feature data but no pricing. So what we have been given in this question is that Charlie is a boy who wants to buy a house, and when he wants to buy a house, he will obviously make some observations about different houses and he will compare the houses based on certain features. So in our case, Charlie has noted F number of features. Okay, so F number of features he has noted, and each row F contains separate values followed by the house price. Okay, he has noted various features for various houses. So he has F rows where F values are the features of the houses, and the last column, which is the F plus 1 column, is the column which has the price of the house, price in dollars per square foot. Okay, so the total columns are F plus 1 columns, where F are the number of features and plus 1 is for the price of the house. So, but if he has made the observation about H houses, which means if the observation table has H number of rows, then the total observations are F plus 1 into H entries. Here nothing, F plus 1 is nothing but the number of columns and H is the number of rows, which means he has total of these many observations or entries. So next, once he has the observation data, but he was only able to get the price per square foot for certain houses. Okay, so he only found the prices for certain houses and not for some rest of the houses. So for rest of the houses, he has only got the features and not the price. So for that houses, we need to predict the price of that houses based on the given features. So we need to help Charlie to predict the pricing data for the houses remaining that he was not able to get the prices. So this was the question. Let's understand the sample input. This is the sample input where you have F over here. F and N are the first two variables that you need to input. Here F is nothing but the number of features, okay, and the 7, which is N, is the number of rows or the number of observations. Okay, so H in the question is similar to N over here. Okay, number of rows. So here 2 is the number of features, and whatever values over here you see that there are 7 rows. 1, 2, 3, 4, 5, 6 and 7, which means 7 rows are present as given by this number N7. And here 2 is the number of features, which means in these 3 columns, there are 3 columns, right? So these 2 columns are the feature columns, and the third column is nothing but the F plus 1 column. We saw in the question that our F plus 1 column is the price column, correct? The price of the house column. So this third column is nothing but the prices data. Here, as you see, 109.85, 155.72, this is the prices of the houses. And these first two columns, which are the decimal numbers, 0.18, 0.89, 1.0, 0.26, these are the feature values which are scaled between 0 and 1 by Charlie. Okay, and next we have 4. This integer number 4 is the observations, the number of observations which have no price. As you remember in the question, Charlie had found the prices only for some house, and for other houses we have to predict the prices. So this 4 will denote the number of houses for which Charlie hasn't found the prices of the house. Okay, and we are given 2 rows over here. These rows are nothing but the feature values, and we need to predict the entire third row, which is the prices of the house. So this was the sample input that we have got. I hope you're clear with whatever input and variables that we have been given. And finally, we have the sample output. So this is nothing but the last row that we want to predict. This last row which is missing over here, this for the 4 values. See, we have 4 rows in this and also 4 in this. So this is nothing but the predicted house prices for which Charlie hadn't got any values. So this is the 4th row for these given features. Using these given features, we have predicted this output of the price of houses. So let's begin with the coding part of this question. We will be applying simple linear regression because, as you can see, the prices are dependent on whatever feature values that have been given. So this is an example of multiple linear regression. So let's begin. First, we will import NumPy, which we will be using in our coding. Okay. So for that, import NumPy as NP. NP is the alias name, as we do always. Next, what we will be doing is we will be importing linear regression. So from sklearn, import linear underscore model. Okay. So once we've done this, we have imported a linear underscore model. Next, what we will be doing is we will be creating 3 functions in this solution. The first function will be for getting the input, for reading the input. Because as you can see, the input is in this form. So we need to properly put it up in an array or in a list or in a specific data type, because we cannot use this raw data to train our model. We need it in a specific form. So for that, and we also need the training and testing data as well. If you observe properly, then whatever this above data is given, these 7 rows and 2 columns are nothing but the training data. Because we know that in our training data, we have the value of the target variable as well. So these are the values of the target variable, which is nothing but the price of the houses, correct? And these 4 rows are nothing but the testing data for which we have to predict the house prices. So these 7 rows are the training data and these 4 rows are the testing data. So by using this function, read input, we will be getting the training and the testing data separately from whatever input we are giving. Okay, the second function that we will be creating is the predict function. Okay, the training and the predicting function. And the last function will be the combination of the first 2 functions that we have created. We will be applying that 2 functions on our data and we will be training our model. So let's first create the read input function. So now first, before beginning, we will create 2 lists. First, which is the train data, and next, which is the test data. As you know, we will be storing our train and test values in this list before transforming it into an array. So train data and test data are the 2 lists that we have created. Next, what we will be doing is we will be accepting these f and n values. So as you can see in the sample input, they have been given in a straight line, 2 and 7. But how do we understand that which one is f and which one is n, and how the system will understand it? So what we will be doing is we will be splitting this input. Okay, so f comma n. These will be the two variables in which the f and n values will be stored. F value will be stored in f, which means the 2 value will be stored in f and 7 will be stored in n. Next, what we will be doing is map. We will be applying the map function so that we get this input in the integer form. Okay, I'll explain it to you, don't worry. Then input function, as we know, input function is used to accept the user input. So input dot split, because we saw that the data was present in a single line. So we need to split the data based on a space. Why space? Because these are space separated integers. So that is why we will use the space to separate this 2 and 7, so that it can be splitted in 2 separately and 7 separately. Okay, so what this line says is that it will first accept the input, then it will split it. After splitting, it will get 2 parts. First is 2 and second is 7, correct? So what next it will do is it will use the map function. What it will map is it will apply the int data type to both of these numbers. Okay, so both these numbers will get converted into int. Why? Because when we pass certain input, it is in the string form, but we don't want it in the string form because they are numbers. So we will apply the map function, which will convert our strings into int. Map function works like this, as given in this particular diagram. You can see that if we have a certain function, okay, like in this example, we have return x into 2 and we have a list of numbers. So what map will do is it will accept this function, it will accept this iterable, which is in our case list, and it will apply this function to every element of this list A. See, a is equals to a is equals to 1, then it will apply function to the number 1 and it will give the output. Similarly, a is equals to 2, then it will apply the function to this number 2 and then it will give the output as 4. Okay, then it will give the output list. So this is the function of map, that is it will take a function and apply it to all the input that we have been given. So after getting the f and n, our next work is to get all these 7 rows as input. Okay, so what we will be doing is we will be appending all the information into this train data, correct? Because it is our training data. So train underscore data dot append. We are using the concept of list comprehension over here because it will save our space as well as time. So input, here also we are using split because the data is being entered in a single line. So we need to understand what the system needs to store the data differently, correct? So we will be separating it using this split function, and for we'll be applying for loop over here for underscore in range. The range will be nothing but 0, n. Why 0, n? Because we know that the number of rows is n, correct? The number of rows is 7, which is nothing but n. So it will run a loop from 0 to n to accept the single rows. Suppose from 0 to n the first number will be 0, then it will accept the first row. Then the next will be 1, then it will accept the second row. Next it will be 2, then it will accept the third row. Next, in the for loop, the value will be 3, then it will accept the fourth row. Okay, such looping will be done to accept the 7 rows, which will be ranging from 0 to n. Okay, and we will be appending these numbers in the train data. So by splitting it with a space. Okay, now next what we will be doing is, after getting the training data, we will be accepting this integer 4, which is the variable t. Okay, so t is nothing but the number of data for which Charlie has no price of the houses. So this is the t, and we will be applying a similar step as given in this for the training data to get the values for testing data as well. So test underscore data dot append. Here also we will be using input and we will be splitting it because the testing data is also given in a similar way, but the difference is that only that the prices column is not given, and your range will not be 0 comma n, it will be 0 comma t, because as we know we have used t as 4, and we are accepting the testing data, which means it will be 4 rows. So for that we will be passing the value as 0 comma t. Whatever number of missing data we are present with, it will apply that number for looping, and it will accept that many number of rows. Okay, so we have done with accepting the testing data. Our next work is that we will be converting these lists to array so that it is easy for the model to train. So train underscore data equals np.array. Okay, what this will be doing is it will convert our string, it will convert our list into array. I have applied the array function, and what will be input to this function is nothing but the training data, because we want to convert the training data only, and we'll be passing the data type. Okay, what data type we want to apply to our elements is np.float64. Okay, because the data that we have present is in the decimal form. Okay, so we want the data to be in the decimal form only, so we will be passing the data type as np.float64. Similarly, we will be converting our training data as testing data as well. So for that, similar code will be applied, and only in this place, in the train place, you will put test over here and test here as well. So once we are done with applying the array function, next our work is to store this train and test data in proper variables. Okay, because for now in our train data we have all the 3 columns, correct? 0.18, 0.89 and 109.85. We have all the 3 columns, but for training, for the train data, we want only the 2 columns, correct? We will be separating now our dependent and independent features. In our case, the dependent feature is the price column, the last column, which is the Y train. And the independent features are these 2 first columns, which are the X train. Why X train? Because those are independent columns of the training data. And why Y train? Because those are the dependent columns of the training data. Similarly, here we don't have the dependent column, but we have the independent columns. So for independent, we use X, and this is the testing data. So this data will be the X test data. So now we will be separating the data based on dependent and independent features. So first, let's do it for the independent features of the training data. So X train equal train data. We want all the rows, but only condition is applied on the columns. So we'll be using all rows and only 0 to F columns. Why F columns? Because the number of features are F, as we have been given in the problem, and we have also stored the value of F in this variable F. So F is nothing but the number of features. So in our case, the number of feature is F, which is 2. So it will accept only 2 columns. So we are using this colon. This single colon means all the rows are accepted, because we need all the rows, correct? All the rows, but only 2 columns. So for 2 columns, we are using 0 to F. And similarly, now we have the Y train. Y train will be nothing but the last row of the training data, which means it will be the -1 row. Why -1? Because the last column in our case is the price column, correct? So the price column is our dependent column. So in Y train we are storing the independent column, which means the last column, the -1 column. And similarly we need all the rows. So colon comma -1. So it means it will accept all the rows but only -1 column. Now we'll be doing it for X test, which means the independent features of the testing data. So independent features of testing data is nothing but the entire test data. Why? Because we don't have any dependent feature, right? We are missing with the dependent feature which we need to find. So the entire data is the test data only. So we have passed this. This will be from. Okay, so now let's run this code to create the function which is the read input function. Once we have been done with creating the read input function, we will be now using the linear regression to fit our model and also predict the output. As you all know, linear regression is used to find the best fit regression line for a sample of inputs. As you can see, the blue dots in this graph represent the samples, and this red line is the regression line. Your X are the independent features, which means the features that we already know, and Y are the dependent features. That means the features that we want to predict. In our case, X features are the two columns, the feature columns, and the Y is nothing but the price data, which means the price of the house. So we in our case also we will find the best fit line and then the last row or the last column for this test data which we want to predict. So let's move ahead for creating the fit and predict function. The fit and predict function will accept the data which is X train, Y train, and X test, and it will apply the model on the X train and Y train. It will fit the model with the X train and Y train, and it will predict the model using the X test. So let's begin with the coding. What we'll be doing is we'll be creating the model. Will be storing the model in the model variable, and simply we'll apply the linear regression model. So linear model is the library that we had imported, and we'll be applying the linear regression in this case. So linear regression and create the object. Next, what we'll be doing is we'll be applying the fit method on this model to fit our model, and we'll be simply passing the training data, because the training data is only used to fit the model, which means to train the model. In simple words, fitting is nothing but training of the model. So for training, we will obviously use the training data. So model.fit X train, Y train, and once we train the data, our next task will be to predict the data. So the predicted values will be stored in X test, because what we want to predict? We want to predict the last column of the testing data. Last column is nothing but the independent column. Independent column is represented by Y, and this is for testing data. So Y underscore test, and we will be applying the predict function to this. So model.predict, and we will be passing, for prediction we always use the testing data. So we will be passing the X underscore test that we have created. Okay, and finally we will be returning the Y test values with this function. So run this function to create it. So it has been created. Now we'll be applying the two functions that we have created to the data or to the input, which means in this function, in the main function, we'll be accepting the input from the user. So let's accept the input. For that, first give three variables, X train, Y train. Okay, in this we'll be storing the values, whatever we are getting from the function, and we'll apply the read input function. Read input function, if you remember, is the first function that we have created, which will accept the input from the user. So whatever value it will return, see, it is returning X train, Y train, and X test. So it will be stored in this function. It will be stored in these three variables once you apply this read input function. Okay, the read input function is applied. Next function we had created was fit and predict function, and we will be storing the result. This result will be nothing but the y-test, because our fit and predict function is returning the y-test values. So we will be storing it into the result variable and apply the fit and predict function. What the fit and predict function is accepting as input check, it is accepting the xtrain, ytrain and xtest. So just pass these three values to our function when you call it. Okay, once you pass these values, our next task will be to return some value that we can print. So we will be just returning the y-test value, but we need to print it in a proper format, because as we have been given in the sample output, you need it one value on one line. So for that, we will be joining the new line function, okay, the new line character with the result values. So it will join the new line with this list map, and we'll be again converting the values to string. Why? Because join function can be applied on only string values. So that is the reason we will be applying the map function. What map will do is it will apply the string function to the all values of result, and result values are nothing but the output that we have found. Output as in the price of the houses that we have found is stored in the result. So it will apply string to all these prices. Once it applies string, it will be converted to list, and it will be joined with new line, which means each element of this list will be printed on a new line. Okay, so let's create this function as well. Once you've created this function, now we will call this main function and store the values, whatever values you get from this main function, in the prediction column, in the prediction variable, and finally print this prediction variable. Okay, so this function, the main function, is returning what it is returning, the values, the output values on new line, correct? So it will be stored in this prediction variable, and finally we will be printing the prediction variable. So now let's run this prediction variable. This prediction variable will first ask you for the input f and n. F is the number of features, n is the number of variables. Sorry, the number of rows. So we have 2 features and 7 rows, correct? Print enter. Our next input will be the data. See, in the sample input, you can check after entering 2 and 7, you need to enter all of these 7 rows, but one by one. So I have this input separately. So I'll just copy these values over here. Again, press enter, and you need to just do it line by line, so that it will accept the input also line by line. Here, if you notice, then it is running the for loop, okay, as many as times as you have given the number of rows. So this is the purpose of running the for loop, that it will accept the input separately for each row. Okay, so you need to do this for each row. You can give any values you want, but for making you understand the concept and the problem, I'm just using the sample values only. You can try it with any other values, but we want to confirm our answers, right? So that is why I'm using the values that we have been given in the sample input. Now our number of rows 7 are been completed. So the next input will be 4. 4 is nothing but the number of missing data, correct? And then now the 4 rows which have the features, only the features, that rows you need to pass one by one. In this case also, it is running the for loop, where we had given the range as 0, t. T is nothing but 4, which is the number of missing data. So this is the last row, and once you enter all the data, click enter. Okay, and just as you click enter, you will see these 4 rows at the end. These 4 rows represent our answer, which is the price for these 4 rows of features. So compare the sample output. See, 105.22. Yes, we have got the correct answer. Then 142.67. Yes. Then 132.93, 132.94, yes. We have almost got the approximate answers as given in the sample output. Okay, just as you enter the input, when you press enter, automatically you will get the output because it has been, we have just programmed it in the main function. Okay, so yes, this was the entire solution of this problem. First, we created the read input function wherein we just accepted the data from the user, and we have separated it as training and testing data. Next, then we created the function which will fit and predict the model using the linear regression. Okay, it will fit the model using the training data, and it will test the model, or it will predict the model using the testing data. Similarly, it will apply the main function. Using in the main function, what we did is we applied the read input function and the fit and predict function to our data, and we specified that in what format we want the output. We have given this output in the return statement. And then finally, we applied the main function to get the final output. So this was a easy to understand multiple linear regression problem asked by the company Accenture in its interview round.